Continuing here with another problem of decision tree, the following example is being considered where a dam is being considered to reduce the river flooding. The authority who is building the dam is concerned about the height of the dam. With the following alternatives, they want to find out which height minimizes the total annual cost. Given the interest rate 5% and number of years the dam will be lasting, if it is taken as 50 years, we need to find out the correct height which reduces the chances of river flooding. Under that, we have been given the following datas which are given as height, which are 0, 20, 30 and 40, all are in feet. The initial cost of setting up the dam is simultaneously 0, 7 lakh, 8 lakh and 9 lakh. The probability of the flood occurring if the height is 0 is 0.25. If the height is 20, it is 0.05. If the height is 30 feet, it is 0.01. And if the height is 40 feet, it is 0.002. And if the damage occurs, the flood occurs, the damage in rupees will be, if the height is 0 feet, it will be 8 lakh. If the height is 20 feet, it will be 5 lakh. For 30 feet and 40 feet, the respective damages will be at 3 lakh and 2 lakh. So, given this data, we have to find out the optimum height which the authority should be building to find out that correct height. Coming back to the solution of the previous problem, the easiest way to find out the solution for this particular problem is to choose the dam height with the lowest equivalent uniform annual cost. If we find that, that will give us the actual idea that per annum how much cost is required to operate that height of the dam. So whichever height should give us the minimum cost, that particular height the organization or the authority should be considering while building up the dam. So to do that, we have to take into consideration the initial cost. Though the initial cost is actually given in present worth, we have to convert that into annual worth respectively so that we can get the annual worth of the initial cost. So first, if dam has not been built, so obviously the initial cost will be 0. Moving on, from the 0 feet to 20 feet, if the actual initial cost was 7 lakh in case of 20 feet, if we convert that from present worth to annual worth with the help of 5% and 50 years, which has been aforesaid, the value then transfers back to 38,344. Very similarly, for 30 feet and 40 feet, the respective costs of 8 lakh and 9 lakh furthermore reverts back to 43,821 and 49,299. These two workings has not been shown in the sum. This is for the students to do it on their own. Now, moving on to another aspect where we had talked about that if the flood occurs, what are the damages that we need to take into consideration. Now, this is one thing which we need to understand, that higher the height of the dam will be, lower the possibility of the flood will be. The given probabilities of 0.25, 0.05, 0.01 and 0.002 is in a decreasing order. So actually the theory which I had just mentioned is supporting this. And when we need to find out the total damage or the expected flood damage per height, what we need to do, that the possibility of the flood or the probability of the flood happening into the total damage or the total expected damage needs to be multiplied. That means in the first case, if no dam or 0 feet dam has been built, the annual probability of the flood is 0.25. The damage occurs is 8 lakh. So basically 8 lakh into 0.25 should give me the expected flood damage. Very similarly, 5 lakh, 3 lakh and 2 lakh respectively for 20 feet, 30 feet and 40 feet needs to be multiplied with their annual probability value of 0.05, 0.01 and 0.002, which gives us the figure of 25,000, 3,000 and 400. Adding up those value, we get the total cost. That is, for 0 feet we get it 2 lakh. For the 20 feet, 30 feet and 40 feet, the respective values comes at 63,344, 46,821 and 49,699. So basically, if we take in the context of what we have said earlier, the lowest annual cost should give us the idea or the optimum height at which the dam should be built, and that is somewhere after our calculation it is indicating to a 30 feet dam being built. So the resultant should be the organization or the authority should be looking for a 30 feet dam if they want to minimize their annual cost, and that should be the optimum result for the authority. This is a far more complex but one of a kind example that we will be taking into consideration. These are the kind of problems generally that organization faces day in day out. In this particular example, if we carefully look at it, it's a complex kind of decision tree. What complex kind of decision tree? The organization needs to take a decision whether to build a new product or not. If yes, the product is need to be built, the first cost is nearly of 1 million rupees. And if the organization doesn't build the new product, the cost is 0. If now, when the organization decides to build the new product and the first cost has been invested of 1 million, the volume of production next comes into account. When the volume of the product comes into account, those have 3 different branches coming out of it. What are the 3 branches? For low volume, the probability is 0.3. For medium volume, the probability is 0.06. And for the high volume, the probability is 0.1. When the organization faces a low volume production, net revenue for year 1 is 100,000, and from that, if the organization continues or wants to terminate, the net revenue becomes 0 for the termination, and for the continuation part, the revenue sticks at 1 lakh per year. For the medium volume, the net revenue does not change every single year. It has a 2 lakh per year revenue method. And if the organization is opting for the high volume and the net revenue for the first year is 4 lakh, but here from this particular decision node, the 2 other branches that are being going out, here the organization either wants to expand or wants to continue with the current scenario. If the organization wants to expand the scenario, there is a first cost involved which is at 8 lakh, and after that fixed cost or the first cost involved, the net revenue for the year, the organization is getting it at 6 lakh per year. But if it is continue in the same kind of model, the net revenue works at 4 lakh per year. Now, the decision which the organization needs to take is that the new product should be built or not. And most importantly, it needs to find out the product's expected present worth value. These are the things that we need to calculate. Now, when we need to calculate the product's present worth or the expected present worth, the other criterias which has been given to us is the organization uses a 10% interest rate per annum. Most importantly, if the product is terminated after 1 year, that the organization doesn't want to use it after 1 year, the capital equipment or the fixed cost will have a salvage value of rupees 5,50,000. And if the equipment or that particular fixed assets are being used for more than 8 years or for 8 years, the salvage value becomes 0. So this is the particular example which has been talked about here. In the next few slides, we will be trying to solve this particular problem. Coming back to the calculation part here, this particular decision tree, as I said, is a complex one, and this particular decision tree's evaluation, we can start off by the end nodes, and the decision will lead to them. In this case, the decisions basically are whether to terminate that after 1 year, that is for the first option, and whether to expand the sales after 1 year, which is in the third option. If you go back to the previous slide, here the decision to terminate the product depends on which is more valuable, the equipment salvage value of 5 lakh or the revenue of 1 lakh per year for 7 years. The present worth of the salvage value is 5,50,000 if we terminate that low volume production. If we terminate that, so the first node that we are having at node 7, if you go back by node 7, that is of net revenue of 1 year, where we are having, out of that 2 branches came out, that was one was terminate or one was to continue. So going with the terminate column, if we go with the terminate node, the terminate node should give us the 5,50,000 value, right? And the continue column should give us a revenue of 1 lakh per year, which is basically annual worth by nature. So what we need to do, we need to transfer that value into present worth. So when we are transferring the 1 lakh value from annual to present with the help of 10% and 7 years, we are getting a value of 4,86,800. So now coming back to the decision here, if we clearly see that the terminate value of 5,50,000 is greater than that of the value of 4,86,000. So if we try to decide now that if we go with the higher the better, then we keep the terminate column and we just prune that continue column. If we do that, so from the low volume, one single option remains, that is terminating that low volume production and getting 5,50,000 back, and most importantly using the fixed asset into other sections. The second decision which was there with us that needs to be taken at the end node is coming back to the high volume production, where the high volume production required a decision of either expanding or continuing with the same production rate. If we expand, we had already taken into account a 8 lakh initial cost. So what should be the decision? The decision at that expanding node is based on whether that 8 lakh first cost for this expansion is greater and justifiable on increasing annual revenue for 7 years by 2 lakh per year. As we can see, initially first year the revenue is 4 lakh. After expansion, the net revenue increases to 6 lakh. So that extra 2 lakh revenue, is it worth it? So to calculate that particular aspect, what we do for node 9, as we can easily see here, at node 9, we need to transfer all the values into present worth. So 8 lakh, since it is an initial investment, it is already in present worth and a negative value. And for that 8 lakh we are getting back how much? 6 lakh per annum. That is an annual worth to us. Transferring that into present worth, given 10% and 7 years, after calculating we get the value at 21,20,800. This is for node 9. Or if we try to expand it, if we keep the production at the same level, the next node, coming back just to the next node, that means we get 4 lakh per annum fixed for the 7 years. So that is plain and simple 4 lakh annual worth which needs to be transferred into present worth for 10% 7 years. If we transfer that into present worth, we get the value of 19 lakh 47,200 approximately. Now, showing these two values, we are seeing that a differential value of 1,73,600 is more with the expansion node, right? So as we know, inflow always higher the better. The expansion should happen if the volume is high. So basically we need to continue expanding the volume and take in node 9 and just prune out node 10. Now in this particular slide you will see what we have done in the previous slide. As we talked about, if the low volume production is there, we are trying to keep the terminate node and we have pruned out the continue node as the value was lower. If you see, I have put a double cross or a double dash on that continue node to make us understand that that particular node is not better for the organization and it should be working with the terminate node which is at 5,50,000. Very similarly, if you come back to the higher volume production, you can see that I have pruned out or double crossed the continue node which has a lower value compared to the expansion node which is, I had previously said, had a higher value or a differential value of 1,73,600. So now if we have pruned this, if we now come back to which volume to keep and which volume not to keep. Now if we transfer the values back to the node 4, 5 and 6 which are the low, medium and high node. For node 4, if you look back very carefully, there is an initial or there is a net revenue of 1 lakh and by terminating we are getting a value of 5,50,000 after 1 year. So basically that's a future worth value to us. So that 6,50,000 which we are having, if we transfer that from the future worth to the present worth by considering 10% and one single year, the value is moving us back to 5,90,915. That is for node 4 or the low volume production. If we move back to node 5 or medium value production basically has a constant revenue of 2 lakh per year. So if we are keeping that for 8 years continued, which we have already taken into account, then that 2 lakh value transferred from annual to present with the help of that given interest rate of 10% moves us back to a figure of approximately 10,67,000. And last but not the least, coming back to node 6 or the higher probability node or higher, should I say, volume of production node, here we can easily see that a 4 lakh net revenue has been taken into account, but there was an initial cost of 8 lakh taken. But most importantly, in return to that, a 6 lakh annual worth for 7 years was also taken into account. So this 4 lakh and this negative 8 lakh are already in present worth. So we can just deduct that and we can get a value of negative 4 lakh. And then we need to transfer the value of 6 lakh per annum, which we need to transfer it from annual worth to present worth with the help of 10% 7 years. That particular value needs to be transferred, and most importantly, this entire value this entire value needs to be transferred from future to present to make it the present worth at node 6. If we do that, that particular value is coming at 22 lakh 91,660. Now, if this is completely done, these are the three single values which we are getting at node 4. Again, I am repeating, the value we are getting after calculating every single thing is 5,90,000 approximately. At node 5, approximately we are getting a value of 10,67,000. At node 6, we are getting a value of 22,91,660. So what I had said previously on keeping on calculating from the last, so that we can come back to the newest or the first slide, if we first node, if we generally say it, this is how we have moved back easily. Now when we need to consider the probabilities which are there. So for node 4, what we are seeing, that the expected present value is coming at 5,90,000 approximately, and if we multiply the probability associated with it, we get that figure of 0.3 into 5,90,915. Plus, if we do the same for the medium and the high production volume, we get the total figure of the expected value of present worth at node 2. That means where we had invested the first cost of 1 million, we are getting the value back at 10,46,640. So we have successfully now come back to the initial decision point where we have two remaining decisions. What are the two remaining points that we are having? That if we build the new product with the help of 1 million rupees, it is giving me back 10,46,640, and if we terminate it, there is no cost involved in it. So if we deduct that 1 million from the 10,46,640 earned, we have a profit of 46,640 as we build the new product and we continue it for 8 years after considering every single option. So basically 46,640 is the profit amount against the option of 0. So the organization at the end of the day should be investing in this particular project and should be building the new product and also considering the furthermore options which has been shown here. That means the low volume termination should be done, the medium volume should be kept continued, and for the high volume the continuation part should be pruned but expansion part should be continued. Keeping this in mind, the organization should earn at the end of 8 years a profit of 46,640. This is this particular solution for this complex decision tree. As we have in depth talked about the examples of decision tree and what do we mean by the entire decision making process and how it helps the organization picking up the right kind of alternative, let's come back to the discussion of the advantages of the decision tree. The first advantage of the decision tree is that it depicts most suitable project or solution, which means that it has an effective mean of picking out the most appropriate project or solution after examining or taking into consideration every single possibilities which are there with the organization. The second advantage is the easy data interpretation. Most importantly, the decision tree, as we have shown in our example, eases out the process of segregation of the acquired data into different classes so that it becomes very similar kind of data and can be easily compared with each other. The third advantage is to assist multiple decision making tool. It not only benefits the decision maker by providing input from other analytical methods like the nature's tree, where we can take the help of nature's tree in order to get the entire decision tree working. Most importantly, this particular technique takes into consideration the quantitative as well as the qualitative variables for better results. Another very important advantage of decision tree is that this particular phenomena, which is structured and in detailed calculation, also facilitates the filtration of the relevant data and helps the organization picking out the exact alternative which the organization is opting for. Though we have praised the method of decision tree to its fullest, as every single method has some limitations attached to it, decision tree is not an exception. Since this particular decision tree calculation is a non-parametric technique, it is not suitable for the situation where the data classification is very high or it has a very large amount of data. Most importantly, if there are multiple possible results of every single decision, it becomes very hard to show every single decision on a single decision tree. That is one of the most important disadvantage of the decision tree calculation. Most importantly, if the decision maker is a less experienced one, he generally has a tendency of not handling this much amount of data and might make a mistake of putting a particular variable into its similar kind of classes. Even a slightest of change becomes problematic in this decision tree calculation, as the result can completely vary on that particular mistake. So while calculating decision tree, it is one of the biggest challenge for the decision tree maker to be absolutely concentrating on the multiple variables, and most importantly try not to make any single error in the decision making so that it leads to a different kind of decision to the organization. So basically these are, and most importantly, one common disadvantage of decision tree is also it is very much time taken and it is to some extent very calculative method, and most importantly it doesn't immediately give the organization a certain decision. It has to take in different kind of variables into aspect, then only it can reach to the exact decision. These are basically the disadvantages of decision tree.